Welcome to this module on cloud service types. Today, we will focus exclusively on infrastructure as a service, commonly known as IaaS. This is the foundational layer of cloud computing where you rent IT infrastructure on a pay-as-you-go basis. Let's explore how IaaS works, its economic model, and when you should use it. To begin, let's define IaaS. It is essentially the delivery of computing infrastructure as a service. Instead of buying hardware, you rent resources like servers, virtual machines, VM, storage, and networking components. In this model, the cloud provider, such as Microsoft Azure, takes responsibility for the physical facility. They manage the data centers, the physical servers, and the virtualization software that makes the cloud possible. Your role starts at the operating system level. You provision a VM, and then you are responsible for managing that OS and everything installed on it, just as you would with a physical server in your own office. This flowchart visualizes the separation of duties. The top section shows the user, who is responsible for the operating system and the applications and data running on it. The bottom section shows the cloud provider. They manage the heavy lifting, the virtualization layer, the physical servers, and the underlying networking and storage hardware. This abstraction allows you to focus on your software without worrying about hardware failures. IaaS operates under a specific shared responsibility model. Among the cloud service types, IaaS places the maximum level of responsibility on you, the customer. While the provider secures the physical perimeter, you are responsible for patching the operating system and configuring network controls, such as firewalls. You effectively rent the hardware, but you own the security of everything you put on it. This means you must actively manage endpoint protection, data encryption, and identity access to ensure your environment remains secure. This diagram breaks down the IaaS model into two classes of responsibility. The top block details customer responsibility, highlighting that you control the data, applications, OS, and network configuration. The bottom block lists provider responsibility, which is limited to the physical realm, hosts, networks, and data center utilities. This visual confirms that in IaaS, the digital assets are entirely your domain. An IaaS solution is built from several core components. First, there is compute, typically provided as virtual machines running either Windows or Linux. Next is storage. Unlike temporary storage, IaaS uses durable disks for the operating system and data, ensuring data persists even if the VM is rebooted. Finally, we have networking. You deploy these VMs into a virtual network, or VNet, and use components like load balancers to distribute traffic and public IP addresses to communicate with the Internet. Here we see a standard IaaS deployment. The Internet traffic hits a load balancer, which distributes the work to two virtual machines inside a virtual network, VNet. Each VM is connected to its own persistent OS disk. This illustrates how the compute, storage, and networking components work together to form a functional infrastructure. Financially, IaaS represents a shift from capital expenditure, or CapEx, to operational expenditure, or OpEx. You avoid the upfront costs of buying hardware. Instead, you pay for compute resources based on usage, typically per minute or second. Crucially, if you stop and deallocate a VM, you stop paying for the compute charges. However, remember that storage is billed separately. Even if the VM is stopped, you continue to pay for the persistent disks that hold your data. This state diagram explains the billing logic. When the VM is in the running state, you incur both compute and storage costs. When you transition to stopped, deallocated, the compute cost is paused, saving you money, but the storage cost remains active because your data is still being preserved on the disk. IaaS is often the preferred choice for migration strategies known as lift and shift. Because IaaS VMs function like physical servers, you can migrate applications from on-premises data centers to the cloud with minimal or no code changes. This is the fastest migration path because you are simply replicating your existing infrastructure in a cloud environment. It is particularly useful for legacy applications that depend on specific operating system versions or configurations that PaaS offerings might not support. This diagram illustrates the lift and shift process. We move from the on-premises environment on the left to the Azure IaaS environment on the right. The legacy server is mapped directly to an Azure VM. Notice that the legacy app remains unchanged during this move, highlighting the compatibility and ease of this migration strategy. The defining trade-off of IaaS is between control and management overhead. IaaS provides maximum control, giving you full administrative access to the virtual machine to install any software you like. However, this freedom comes with a management burden. Unlike PaaS, where the provider manages the runtime, In IRS, you must manually handle all software updates, security patches, and middleware configurations. It offers the highest flexibility, but requires the most maintenance effort. This chart compares cloud models. The x-axis represents control, and the y-axis represents management effort. IRS sits in the top right quadrant, indicating that it offers high control, but also requires high management effort from you. In contrast, PaaS and SaaS are lower on both scales, illustrating the trade-off you make when choosing a service model. To wrap up, let's look at when to use IRS. It is perfect for test and development because teams can set up and tear down environments in minutes, avoiding hardware delays. It is also widely used for website hosting, allowing you to run standard web servers like IIS or Apache with full configuration control. Finally, IRS is powerful enough for high-performance computing, enabling you to run complex simulations on computer grids that would be too expensive to maintain on premises. This mind map summarizes the key use cases. Branching from the center, we see dev and test focusing on speed and disposability. Web hosting highlights the ability to run custom servers. Big data points to high-performance computing capabilities. These branches represent the versatility of IRS in solving diverse business problems.